What I'm going to talk about this morning is what I've learnt about lambdas and streams in JDK 8. So let's have a quick show of hands. Who here is using JDK 8? Aha, good, excellent. Who's tried JDK 8 if they're not using it at the moment? Okay, good. So I'm going to assume that most people here have at least got some experience of JDK 8, lambdas and streams, which is very good for me because it saves me having to go through the basics of what lambda expressions are and what the streams API is. I've only got half an hour, so I've had to sort of shrink this presentation down a bit, and I've left out that little bit at the beginning. Now, the idea behind this is really comes down to a phrase, a saying that I came across a long time ago. I have no idea who said it, but it's very relevant because it says, a clever man learns from his mistakes. A wise man learns from other people's. So today, I am going to be clever, you are going to be wise. Now, first thing to talk about is how you can use lambda expressions in terms of delayed execution. And this is a nice little feature that was added in terms of JDK, which you might not be aware of and might be very useful in certain situations. So here's what we might do in Java. Now, I know we all use the standard logging API in Java. We wouldn't use any of those other, third-party things like log4j or anything like that. So this is a typical piece of code that we might have if we were using the standard logging API. And this kind of demonstrates Heisenberg's uncertainty principle applied to software. And for those of you who are not quantum mechanics majors, Heisenberg's uncertainty principle states that the act of observing something changes what you're observing. And that actually applies just as well in terms of software. The problem we have is if we call this method logger.finest, what we need to do is pass a message to it so that that message can be logged if it's needed. And so we have a method called getSomeStatusData. And that could be a very heavyweight operation. It could take a lot of time to generate the message. And in order to pass the message to the finest method, we have to call that method, we have to generate the message. Then, when that message gets passed to the finest method will look at it and go, oh, let's see, are we at logging level info or are we at logging level finest, and decide whether to use the message. So regardless of what level you're at, you're always going to have to generate the message. So the problem is that if you set the logging level to info, you're going to have a performance impact because you're generating this message that you don't actually use. As soon as you get to finest, throws it away, returns. So whatever we do, we have to call that, we have to generate the message. Now in JDK 8, there is a functional interface, which is called supplier. And supplier is a very simple interface. It has one method which returns a value. It doesn't take any parameters, it just returns a value. And all of the logging APIs, the standard logging APIs in Java, have been modified so that in addition to having versions of the method that take a string, they also have versions of the method that takes a supplier. Now, supplier being a functional interface means we can use a lambda expression in order to represent that functional interface. And so what we can do is we can actually change our code very subtly. We can literally add, like 6 characters, and we can change the way that works. So rather than passing the result of getSomeStatusData, we pass a lambda expression. And now the lambda expression, because it's a supplier, it doesn't take any parameters, and the body of the lambda expression is to call getSomeStatusData. So it's a very small, subtle change in terms of what we're doing in our code, but it can have a big impact in terms of performance. Because now, what we're doing is we're passing a description of how to create that message, not the message itself. That way, when finest gets called, and it decides it's at level info, so it doesn't need to do anything, it returns without doing any work. If it needs the message, it knows how to create it, it calls the method on the supplier, generates the message, and then logs it. So it's only when we need that message that we actually use it. So that can definitely improve performance in terms of that type of situation where we're using a logger. But the nice thing about this is if you have a situation where you're passing a value to a method and you're not sure whether you're going to use it, and it's something which has a big performance impact, use a supplier, pass the description of how to create it, and then use that only when you need the actual value in your method. So it's a nice way of avoiding the overhead of calling that method to create something every time. Now, next thing I want to talk about is avoiding loops in streams. And this is all about how you think when you're writing code. So as I did a show of hands, and pretty much everybody here is using JDK 8, so you've done some Lambdas, you've done some streams. But here's another interesting question. Who here would describe themselves as a functional programmer? Okay, yeah, I mean, there will be not many people, actually. Interesting. And that is actually an issue, because Lambdas and streams introduces a functional style of programming to Java. It's something we haven't had before. And for Java programmers, we're very used to imperative style of programming. And functional programming is different. You have to think differently. Now, if you look at the differences between functional and imperative programming, one of the key things with functional programming is that you shouldn't modify state. So when you do things, there must be no modification of state. It's the idea that a function, as a mathematical function, you can pass in the same value as many times as you want and get the same value out. So the function itself doesn't maintain any state which would affect the result that's being generated by it. So that's very important. And it's also very important from the point of view of allowing things like streams to work very well if you want them to do things in parallel. If you're not modifying state, then you can do things in parallel without having to worry about contention, locking, and all those sorts of things. The problem we have as Java developers is that state is very useful. You know, think about it. When you write code, you've got variables, and you manipulate those variables, and that's what we do in Java. So having state is very useful. Telling people that they can't use state then has to make them think a bit differently. So let's look at some examples of how that works. So when I first started using JDK 8, back when it was first released, I was working for Oracle at the time, and I thought to myself, right, what I really want is a list of all the places where I can use Lambda expressions. I want a list of all the places where I can get a stream from, because there were a whole bunch of things that we introduced as new APIs. And nobody had actually documented that. There wasn't a nice list that was available. So I thought, right, I'm going to do this myself. And I wrote some code which literally scanned through all of the Java docs and looked for all the functional interfaces, looked for all of the places where you could use functional interfaces as parameters to methods, and all of the methods that returned a stream as an object. And I thought, right, so I've generated all this information. I want to print out a summary of this. And one of the things I wanted to do was to count the number of methods that returned a stream. And I thought, right, I'm using lambdas and streams. I'm going to use that to actually write the code. And here's the kind of code I came up with, well, first attempt at my code. So I said, right, I've got a hash map which contains keys, which are the classes in the Java standard APIs. And then the values associated with that is a list of the methods that return streams. So if I want to count up how many methods there are, what I do is I take my key set and I then iterate over that. So I thought, right, I'm going to do that with a stream. So I'll take the key set, create a stream from it, and then what I want to do is for each of those, I want to find out how many methods there are and count them up. So I thought I'll use for each, and then I'll look at how many methods there are and add them up. But I know that I shouldn't be modifying state. So what I'll do is I'll use this other class called longAdder. And this is specifically designed, introduced in JDK 8, for this sort of situation, where you've got many threads which are updating the same variable at the same time, but you're doing frequent writes and infrequent reads. So the advantage of that is that the longAdder will allocate an instance of the variable to each thread, so it can update it independently without locking, and then when the value is required, it combines them all together and returns a result. So I thought, that's thread safe, that's all good, I'll do that. And I got the result. It worked. Nothing wrong with that code at all. And I showed it to one of the engineers at Oracle, who was one of the streams engineers, and he said, oh, no, this is wrong. You are modifying state. This is not functional programming. So I thought, okay, I will have another crack at this then. And I went back and I thought, right, I'll do it this way. So now we have proper functional code. So in this case, what we do is we take the stream, and rather than doing for each, we say take the class that's the key in our set and map it to an int, which is the number of methods that return a stream. And so we get a value from that as a stream, and then we pass those into a terminal operation sum, which just adds them all up and gives us as a result. So in this case, we now have functional programming. So this is all good. But then I had another part of this where I wanted to do two things at the same time. So now what I was looking at is the methods that take a parameter, which is a functional interface, so we can use a Lambda expression to represent it. But in addition to in addition to printing out those methods, I also wanted to count how many of those were new in JDK 8. So I'm actually trying to do two things at the same time. Similar approach for my first attempt, which was to say, okay, we'll create our stream, we'll use a long adder again, we'll do a for each. This time we've got a slightly more complex Lambda expression, and we're going to print out the name of the method, and then we're going to test to see whether it's new, and then add one to our long adder. So we know this is wrong, so we have to do it a different way. So I thought, okay, let's try a different approach. I thought, right, we need to remove the state from outside of the stream, so I did it this way. I thought, okay, I'll do a map to int, same as I did before, but this time what I'll do is I'll record a value, which is either going to be 0 or 1 for whether it's a new method or not. And then I'll print out the name of the method and return whether it's a new method, 0 or 1. That way I get a stream of zeros and ones as my stream, and I can pass that into sum, add them all up, and get the result. So I showed this to my favorite engineer, and he said, oh, no, it's still not functional, because although you're not modifying state outside of the Lambda expression, you shouldn't modify state even inside the Lambda expression. So it's thread safe, but it's still not functional. So I thought, okay, right, so I need to have another go at this then. So the problem is that we've got this state. Internal state, but still state. So third attempt. So now I thought, right, what I'll do is I will use another method, which is very handy, which is peek. Now, peek allows you to look at the elements of the stream as they go past. Very useful for debugging, because you can actually print out what's in the stream so you can see things as they happen. But in this case, what I'm doing is simply printing out the name of the method. So that's all good. I've done the printing of the method. Then I do a map to int, and this time I'm just going to use a tertiary operator, and I'm going to say if it's a new method, return 1, else return 0. That way I've got no state involved in here. So I thought, great, I've done it now. I'm functional. Went back, showed it to my favorite engineer. He said, it's good, but it's not functional. I'm like, why is it not functional? There's no state. He said, well, you see, the problem you have there is you have a print statement. And a print statement is a side effect. And in addition to not modifying state, to be a functional programmer, you should not have side effects as well. So I kind of looked at that and I thought, well, okay, so you're saying that I can't print something out, but what I actually want to do is print something out. So you're saying I can't do what I want to do. So I said to him, okay, like I'm now beyond my level of functional programming skills. You tell me, what do I need to do to this to make it purely functional? And he said, you need an I/O monad. At which point I went, I'm good. Right. Next, the art of reduction. And again, the need to think differently. Now, when I was at Oracle, one of the things we did with the rollout of JDK8 was to run some workshops where we gave people some exercises in terms of using the Streams API. And so one of those was a nice, simple problem. You had a collection of strings in a file, and what you wanted to do was find the length of the longest string in that file. It's a fairly simple thing. We gave people a hint, which was that the buffered reader class now has a new method called lines, which returns a stream of strings from the source. So if you link a buffered reader to a file, you get the lines in the file as a stream of strings. Great. And the result, or the answer to that, is actually pretty straightforward. What you do is you simply say, take your reader, create a stream source, generate the lines, and then pass that into map to int. So you're converting the stream of strings into a stream of lengths of the string. So we use the method reference there, string length, and then we pass that into a terminal operation max, which gives us the maximum value. Great, so now we're finding the maximum length of a string in our file. And then because max returns an optional, we need to extract the value from that, so we just do get as int. Good. Now, when we were doing that, somebody came up to me and he said, well, that's an interesting puzzle, but what about if I change that very slightly? Rather than finding the length of the longest line in the string, in the file, what about if I just want to find the longest line in the file? So I thought about that, and I thought, okay, that's an interesting sort of thing to do, because as we'll see, state in that case is very useful. So I came up with what I call the Naïve stream solution. I thought, right, I want the longest line in the file, so what I'll do is I'll pass the stream of strings into sort, and I'll sort them by length, so that the longest one is the first in that string. Then I can pass that into find first, which simply returns the first element in the string. That's an optional, so I get that result out, and I get my longest line in the string. So that's great. So that works, job done, right? Yeah, okay. Well, not really, because obviously, if you've got big files, you're going to have to sort them. That's going to require a lot of resources, it's going to require a lot of time. It's not going to be the most efficient way of doing things. So I thought there must be a better approach. So the thing I did first was I thought, right, let's go back to basics. How would I do this in Java if I'm not using strings? And this is exactly what we would do. I create a variable called longest. It's a string. I make it an empty string to start with. And then I iterate over the strings in my file. So I say, while there is a line coming from the file, and it's not null, look at the length of that string. If it's greater than the longest string that we already have, then change the longest string and continue. When we get to the end of that, we are going to have the longest string in our file. So I look at that and I go, well, that's great. 4 lines of code, and I've done that. Why would I need to use streams? What's the advantage of using streams over using 4 lines of very simple Java code? And the answer is that this is simple, yes, but it is inherently serial. This is the problem that we have with doing an explicit loop like this, is that we can't simply give that to the compiler and say, make it parallel. So if we had a situation where we had lots of strings, maybe in a list rather than a file, we couldn't break it up into parallel operations and improve the performance by using multi-cores and multi-processors. Even if we did kind of rewrite our loop, because we've got state involved, it's not thread safe. So we pose another problem in terms of multi-threading. So this is the real drawback to doing things this way, and why people have been excited about the idea of streams, is the simplicity of being able to switch to using a parallel approach rather than a serial approach. So actually, let me go back. So one of the things that I then thought is, okay, so how do you iterate over something and do it in such a way that you don't need to maintain explicit state? And this is a very good interview question. If you're interviewing people on Java or even any sort of programming, it's a good question to ask. I know this because Google asked it to me when I interviewed with them. And the answer is recursion. So you can use recursion to, in effect, maintain state as you go through doing something. So I thought, right, let's write the code using recursion. And I wrote a method called findLongestString, and that took an initial string, or the longest string that we had so far, and the source of the strings, and then it said, right, get the next string, test if the string is null. If it is, we've reached the end of our list, go back up through the chain, through recursion, get the result. If the length is longer than our current longest string, then we set longest to the value that we have, and then we call the method recursively to look at the next string. So again, I thought, right, so if we use that, nice simple way of using it, we simply say, find longest string, pass in an empty string, pass in the buffered reader so that we can get our strings and we get our result. So again, I thought, right, no explicit loop, no mutable state. We're all good, finished. Don't need streams. We can do it without streams. We can make this parallel. Unfortunately, not. No, because if you're going to have a very large set of data, then you are going to run into problems. You're either going to hit like an out-of-memory exception, you're going to hit stack overflow, because each line in the file is generating a new stack when you call the method recursively. Too many stack frames, yes. So there must be a better stream solution. This is the whole thing about this, is like, right, let's use streams. So the streams API, if you look at it, uses a well-known pattern: filter, map, reduce. Been around for a long time, well understood. And in the case of this particular problem, we're not actually worried about doing any filtering. So we don't need to reduce the set of data, we just want all the strings in our file. We don't need to worry about mapping, because we got the strings in our file, that's what we're interested in, so we don't need to bother doing any mapping. What we really need to do is reduce. So we want to reduce from the set of strings in the file into one string, which is the longest string in that file. The problem we have then is finding the right reduction. Find the right reduction in order to do that. Now, if we look at the reduce method in the stream API, what you'll find is the signature looks like this. So reduce takes a single parameter, which is a binary operator of type T called the accumulator, and it returns an optional of type T, because there could be a situation where you don't have any input, and so returning a null would be rather bad, so we return an optional. And if you look at the definition of a binary operator is a subclass of bifunction. Bifunction is a function that takes two parameters as input and returns a value. And in the case of bifunction, the types of the parameters and the return type can be different. For a binary operator, all of the types are the same. So we're dealing with same type objects being passed as parameters, same type object being returned. So then we say, right, how do we solve this problem? We need to figure out what the accumulator is in order to use the reduction. And again, if you look at the documentation for reduce, you will see that it says that the accumulator takes a partial result and the next element in the stream and returns a new partial result. And so if you go back to what we did with the recursive approach, you'll find that's a very similar description, except this time we're not generating stack frames because we're not doing it explicitly recursively. We're using the stream to do that for us, in effect the same thing. So what we do is we look at that and we find that the answer is to use this type of reduction. So we say, okay, longest line is take the reader, create a stream of lines, and then just call reduce. And the Lambda expression that we pass in is our binary operator. We're passing in two values, x and y, and then we're going to process those and simply say, if the length of x is greater than the length of y, return x, otherwise return y. So we've got two values, and we return the longest of those two values. Now, the key thing here is the value x, because x is, in effect, what maintains the state for us. So the stream is doing that. So the stream is saying, okay, let's start at the beginning of the stream, look at the string as the first one, that's our partial result, then compare it to the next one, take the longest of those two strings as our new partial result, look at the next one, do the comparison, keep moving down the stream until you get to the end. So there's no stack frames involved. It's not doing it recursively. But x is, in effect, maintaining the state for us, which is the kind of key thing there. But it's not explicit, so we don't have to worry about, from our point of view, multi-threading. If we wanted to make that parallel, it would be very easy. We could simply add parallel to the processing of it, and then the fork join framework underneath could split it into multiple threads of operation, and all the work will be done for us. So I actually wrote a blog post on this, and I showed it to my favorite engineer, Stuart Marks, and I said, look at what I've done. I've gone through this whole process of understanding how to go from finding the longest string in our file, and I've come up with this perfect functional result. And he said, yes, that's very nice, and you've done very well, except there's an easier way of doing it, which is use the max method. So you can use max on its own, which will take a stream of numbers, primitive numbers, and it will return the maximum value of that. But there's also an overloaded version of that, which will take a comparator. as a parameter. And so you can say, take the lines, pass it into max, where you compare the values based on the length of the string. And comparing int is available from the comparator, static method on comparator, so you can use that. And then that will compare the length of the strings by length, but return the string itself. So you're doing the comparison based on length, but still returning the strings as the, or a string as a value in an optional, which you can then get out. So this is really just a sort of learning exercise for me, and hopefully for you as well, to see how you can go through and understand the sort of functional approach to using streams. So just to sort of wrap up then, the key things here are that lambdas and streams are a very powerful combination. It does require you to think a little bit differently. This whole idea of avoiding state requires you to think differently to the way that you do in Java normally. The idea of how you approach things from a loop perspective is a little bit sort of different. And so the key thing here is that if you're writing some code and you're using a stream, and you think to yourself, oh, I'll use for each in that stream, stop and think to yourself, now do I really mean that I want to use for each? Because for each is very easy to use when you think in terms of loops, but it might not be the right approach. Now, there are some very valid places where you would use for each. If you just want to print out all of the elements of your stream at the end, for each is the perfect thing to do. If there wasn't a valid reason for having it, then it wouldn't be there. So just be careful when you use for each that you're using it for the right thing rather than the wrong thing. Think about reductions, think about how you use a binary operator to reduce the stream of data into a sort of set of data or one piece of data. Be careful with parallel streams. I didn't have time to go into this because I only had half an hour for this presentation. But parallel streams are a whole different kind of kettle of fish. And there's a longer version of this presentation, you can find it on YouTube, where I talk more about parallel streams and the way some of it works underneath. Just to be careful with that, because most people seem to think that if you make a stream parallel, it will make things go faster. That's not always the case. One thing I will guarantee is that if you make a stream parallel, there will be more work involved in that stream. It's just that if you've got a lot of data or something that takes a long time to process, you may well finish that work more quickly. There's more coming in JDK 9. There's some new APIs in terms of the streams, which will make things a little bit easier. Probably new things coming in 10 as well. And so I've got about 2 or 3 minutes left. So if anybody's got any questions, happy to take questions. Say again? Yeah, I'm sorry, still can't hear you. So the loop example, yeah?
In the loop, you're doing the sysout.
Yeah.
And also doing something else. I thought you were going to show a better layout.
Oh, I see, yeah. The idea was the side effect of having a print line statement. Yeah, as I say, you would need something called an I/O monad. I don't think it's necessarily an issue, because in the case of what we're doing with that particular piece of code, printing things out doesn't really matter. I think it's only if you were trying to write purely functional code that you would want to replace that. But in terms of that particular piece of code, it's not something that's going to cause any issues, because if you did things in a parallel stream, it would still work quite happily. So yes, you could, in theory, replace it, but I didn't bother going down that route. Anybody else? One more question? Oh.
In terms of the comparison from that reduce to the max taking in its own comparative function, would there be significant bytecode differences about that or performance?
There would be significant bytecode differences because it would do it differently underneath. I haven't looked at the difference in terms of performance. I'm tempted to say, just off the top of my head, I'm tempted to say that the max would be more efficient, but I can't guarantee that. The only reason I would say that is because I know that the engineers spend a lot of time working on the specific APIs to improve the efficiency of them as much as they can. So I would tend to think that that would be more efficient. but I can't guarantee it.
Yeah, I'm just curious. It would seem like the best way to implement maps would be a reduce.
Yeah, without looking, I mean, I might go and look at the code and find that that is exactly what it does, yes. Okay, so I am at time, so come back in like 40 minutes. I'm doing a presentation on JDK 9, so see you later. Thank you.